All right. Hey guys, Mr. Austin here with Algebra 2's lesson 4.1 on graphing quadratic functions. The first thing we're going to take a look at is some vocabulary and make sure that we're all speaking the same language. Let's start with a quadratic function. A quadratic function is basically a function with the highest degree of 2 that can be written in what we call standard form. Let's take a look at what that looks like. So it is a function with the highest degree of 2, which we'll talk about what the degree and stuff is here in a little bit. And it can be written in what we call standard form. Let's take a look at what that is. Standard form is going to look like this. It's y equals ax squared plus bx plus c. That is standard form. So it's a function with the highest degree of 2 and can also be written in standard form, which is y equals ax squared plus bx plus c. All right, let me get rid of that because I kind of ran over into the parabola. The parabola. Obviously, the parabola is the graph of a quadratic function. So it's the graph of a quadratic function. And I think a lot of you are familiar with what a parabola looks like. It's this U-shaped graph that goes on forever, either upward or downward, depending on which way it opens. The vertex of the parabola. The vertex is the lowest or highest point on the parabola. So if I go back to my picture before, this would be the vertex point. It's the lowest point of the parabola. And if the parabola faced down, it would be the highest point of the parabola. The axis of symmetry. The axis of symmetry is basically a vertical line that divides the parabola in half. So a vertical line that divides the parabola in half. And don't forget that that vertical line, I'm going to see if I can get you a picture of it, will always, since it's dividing it in half, it's always going to pass through the vertex point. Yeah, always. All right, our last term that we want to take a look at is min and max. So for the min, the minimum value, that is the vertex's y-coordinate. The vertex's y-coordinate, which I'll show you in just a second. And the max is the vertex's y coordinate also. So in both cases, it's the y coordinate. So you might be thinking, well, wait a minute. How do I know what's what? Well, for the men, it's the y coordinate when a is greater than 0. And the max is when a is less than 0. And here's all that means. If I've got a parabola that opens up, the minimum value, obviously, is right here. It's located at the vertex point. And it's going to be, our vertex is x, comma, and this y is obviously going to be our minimum value. Now, if this thing were to open downward, then obviously we're going to be looking at the vertex again this time. And this point here, you'll have your x, comma, and there is our y value. Again, that's going to be our maximum value. So basically, it's where the parabola gets to its highest point or to its lowest point, but it's always the y value where we find the min and max. Okay, now that we got our vocabulary down, let's take a look at a couple things. First of all, I want to start out with a parent function. We've talked about the parent function already when we introduced the absolute value function, which was the V-shaped graph. We're going to talk about the parent function again for parabolas. Remember, the parent function is the simplest form of this function. So when we talk about the parent function for a parabola, this is the parent function. It's the simplest form of a parabola you can get. If we want to graph this thing, let's take a look at what it's going to look like. Off to the side here, I'm just going to sketch out a little table with x and y. And obviously my simplest point of my parabola that we'll start with is 0, 0. Because when I put in 0, I get out 0. So when I go to graph this, I'm going to start here at 0, 0. All right, and the reason why I wrote 0, 0 where I did is because it's kind of in the middle of that parabola. So for example, if I want to pick 1 and put in for x, obviously out comes 1. If I want to put in 2 for x, I'm going to square it and out comes 4. And if I want to put in 3 for x, I'm going to square it and out comes 9. On the other end, what if I said, hey, I want to put in -1? Well, when I square -1, I get +1. When I square -2, I get 4. And when I square -3, I get 9. Notice these numbers, as you see them, are repeating on each side of that 0. Because that 0, 0, obviously, is our vertex point. So let's plot these, see what this is going to look like. I'm going to go to 1, 1. I'm going to go to 2, 4. Let's see if I can fit 3, 9. Oh, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 9 is going to be off the graph up here somewhere. And then I want to go to -1, 1. And -2, 4. And then, of course, -3, 9 is going to be, again, off the graph somewhere. So when I go to graph this parabola, I'll do the best I can. This is what it's going to look like. And that is what we call our parent function. Again, remember the parent function is the simplest form of our parabola that you can get. Okay, with that in mind, let's take a look at example number 1. It's asking us here to graph y equals -2x squared plus 2. Now, knowing that you have your graphing calculator, I would hope that you would go ahead and get that out right now. And go ahead and hit the y equals button and put in -2x squared plus 2. And we want to compare that to our parent graph. So the first thing I'm going to do is, we just did our parent graph on the last slide. So I'm going to go ahead and plot those points again real quick for my parent graph at 0, 0, at 1, 1, and -1, 1, at 2, 4, and -2, 4. And then go ahead and do 3, 4, 5, 6, 7, 8, 9 fits on this one. And negative 3. 1, 2, 3. 9 fits on this one. So I'm going to go ahead and put on our parent graph so we can see it. This is what we're comparing it to. There's our parent graph. And I'll go ahead and label it parent. Okay, so let's come back and graph this equation with a table. And you're going to see that table on your graphing calculator if you've got it out, so that comes in handy. So when you type in negative 2x squared plus 2, I think you'll notice here are some points that you're going to see. You're going to get negative 2. When you put that in, you get negative 6 out. When you put in negative 1, you get 0 out. When you put in 0, you get 2 out. When you put in 1, you get 0 out. And when you put in 2, you get negative 6 out. Now, I wrote these in this order on purpose. If you'll notice, again, I'm going to show you these numbers are repeating on each side of 0, 2. So what is 0, 2? Well, clearly that's our vertex point. So let's go ahead and graph this thing. Negative 2, negative 6. Negative 1, 0. 0, 2. And then we've got 1, 0. And then we've got 2, negative 6. So now what we're seeing here is the graph of our equation we just put in our calculator and graphed so that we can take a look at it and compare it to our parent graph. All right, so clearly as we look at this, a couple of things that we notice right away is if we were to take a look at this line right here, which is our vertical line that you can see splits both of those parabolas in half, which is kind of interesting, that is actually our axis of symmetry for both graphs. Axis of symmetry is the line that's vertical, which is x equals 0. The vertex point for our red graph, the vertex, I'll put it in red so you'll know, is the point 0, 2. Whereas the blue one had a vertex at 0, 0. You can tell that our red graph obviously faces down. Why is it that it faces down? Because this negative sign right here makes that happen. You can also tell that because the blue one and the red one are on the same graph, I think you can tell from my drawing that the red one is a little thinner than the blue one. So we say that this red graph has been stretched. If you remember my example from class, it's stretched, which means it gets thinner. I'll put that in parentheses so you guys remember. It's thinner. And what is it that makes that stretched happen? It's this number 2 right here. The number 2 makes that happen. When a is greater than 1, that means that it's going to stretch our graph. And the fact that we've got this plus 2 at the end, this plus 2 right here, what is it that that's doing to the graph? Well, you'll notice that that's taking that graph and moving it 2 places upward, which puts us at our vertex point that we mentioned at 0, 2. So several different things that we know about the graph by looking at the equation. Okay, so let's take a look at example number 2. The first thing we want to do in example number 2 is, first of all, notice that this equation, the one that we're looking at, it's already in standard form for me. You got negative 1x squared plus 4x minus 3. Now, just looking at this, here's a couple of things we can go ahead and identify. right away, here's what I know. I know the a value, -1. I know the b value is 4. And I know the c value is -3. And the reason it's important to notice this is because looking at these values is going to tell us some things. First of all, because a is negative, meaning a is less than 0, that tells us that the parabola opens down. So that's something that we know right away. If you remember, we've talked about this c value before, but this c value also tells me something about the graph. It tells me that because it's a -3, that there's going to be a shift that's going to take place. So we'll look for that as we take a look at what we do when we graph this thing. All right, so the next thing we want to take a look at is we want to find the vertex. And there is an actual formula for finding vertex, which you want to make sure you highlight in your notes, and it is this. To be able to find the vertex of a parabola, if you cannot find it on your graphing calculator, and sometimes you can't, is that you can use the formula x equals -b over 2a, and that's why we identified a, b, and c. So if I calculate that, basically the -b would be a -4, because you see b is 4. So -4 over, and on the bottom you see it's 2 times a, and a is -1, so it's going to be 2 times -1. And when we calculate that, you'll notice we're going to get -4 over -2, which just simply gives us 2. Now that is the x value of the vertex point. So let me just go ahead and label right here, vertex, and we just found the x value to be 2. Okay, now that we know the x value, how do we find the y? You'll notice I got the y equals here. Well, this is pretty simple. If we take our x value that we just found, which is 2, and go ahead and just plug it in for this x, and for this x, we'll know what y equals. So if I write it out for you, it's going to be y equals negative, and then we said x was 2, so 2 squared. And I get my squared written on here. I'm going to erase that and rewrite that 2 so you can see it better. It's -2 squared plus 4, and again x is 2, so times 2 minus 3. Now this is going to give me, I'm going to square that 2 first because exponents come first, and then multiply it by the negative, so that gives me -4 plus 4 times 2 is 8 minus 3. And now I can put this together and I get -4 plus 8 is 4, and 4 minus 3 gives me y equals 1. And that's my value for my y for my vertex. So now that I plug this back in, you can see I just found the vertex of this graph. So the vertex is going to be at 2, 1. So I'm going to go ahead and place it on 2, 1, place it on the graph. And then I think what I'm going to do here is I'm going to go ahead and write up this table, x and y, and I just found 2, 1. That was my vertex point. Okay, so my vertex I now know is 2, 1. The axis of symmetry for this thing, well, I got to get it graphed first. So I can go to my calculator and plug in that equation and build a table for this thing. And I'm going to go ahead and just jot down some points from that. You could do it. 1, 0, 0, -3, 3, 0, and 4, -3. So I'm going to plot these points here real quick. That's 1, 0. I got 0, -3. I got 3, 0. And I got 4, -3. So here is a graph of my parabola that I just put on here. Clearly this parabola is opening downward. All right, now, once I got the graph on there, I can clearly see now that this is the vertical line that splits that parabola right in half. And that vertical line is at x equals 2. So here I can tell you, now I know the axis of symmetry and I'll abbreviate here so I can fit it on the axis of symmetry, is at x equals 2. Okay, so next, let's look and see, do we have x-intercepts? Well, we sure do. There's an x-intercept at 1, and there's an x-intercept at 3. So I can list for you x-intercepts, and they are at 1, 0, and 3, 0. Do we have a y-intercept? Well, we sure do. Right there it is on the graph. The y-intercept is at 0, negative 3. And since the a value in this equation was negative 1, 1 being a, and when it's 1, that tells me that this is neither stretched nor compressed. I know all of those things about this graph. All right. So we were able to find several different things about this graph. Let's take a look next at what we talked about earlier about the min and max. I've got a parabola that I can put on here, and I'm going to graph it in red, and I'm going to put it really doesn't matter where I put it, I'm going to place it right here with a couple other points, and we'll open it upwards. Say that it's going to look like this. This parabola right here, because of what we're looking at, we know because it opens up that this has what we call a minimum value. And when it has a minimum value, that means it opens up. And when it opens up, here's what we know. We know that the a value is positive. That's what makes it open up. In other words, we could have another graph on this side, and we'll just place it here, and we'll open it this way, which means it's a parabola that's going to be opening downward. And you'll notice this one has a maximum value. Why does it have a max? Because it opens downward. And when it opens downward, that means the a value is negative. And that's how we can tell when we have mins and maxes. Notice a is less than 0 here, and a is greater than 0 here. That's what we had talked about earlier. All right, moving on to example number 3. They give us an equation. It's in standard form, and they want us to find the minimum or the maximum value. So the first thing I want to do is, in this equation, I'm going to go ahead and identify A, well, it's negative 3, B, well, that's 12, and C, that's negative 6. Now, notice that as I'm looking at this, I say, well, my A value is negative 3. So this right here is pretty important. And this tells me that the A value is less than 0. And that right there tells me that this parabola is going to be opening downward. Now, if I know that it opens downward, I looked at my notes I just did before, that tells me right away I'm going to have a maximum value. And the question was, does it have a min or max? Well, this one has a max because it opens downward. If it would have opened upward, we would have said it had a min. Okay, at this point, there's a couple checkpoint problems that come at the end. I'd like to give you guys a few minutes if you want to go ahead and hit pause, and then go ahead and graph the first function and graph the second function and label what you can. And then after you're done, you can go ahead and hit play and check your work and see how you did on this. So this first graph, I'll quickly sketch a table here, x and y. Some points that I picked are negative 3, 6. Negative 1 ended up being 3.3. 0 was 3. 1 was 3.3. And yeah, you guessed it, 3 was 6, because again we see them repeating we know this is a parabola. That puts my vertex right here. And if I graph those other points real quick, I've got -1, barely up a little bit, and 1, barely up a little bit, and then I got 3, 6, 6, -3, 6. So my graph for this thing is going to look something like this. Got a little mark on there. Let me get rid of that. All right. Now, from this graph, what are some things that we can see? Well, right away, I know the vertex. Vertex is 0, 3. The axis, and I'll abbreviate, of symmetry. The axis of symmetry for this should be x equals 0. That's right here. X-intercepts, interestingly enough, there are none. The y-intercept. Y-intercept, as you can see on the graph, is 0, 3. This thing is compressed, meaning it's wider. Okay, and it's wider because the a value is 1/3. And the last thing, it has a minimum value. And the minimum value is at y equals 3, which is at the bottom of the parabola. Your second example, again, let me put a quick sketch of the table on there. Points I want to use are 0, 2, 1, -1, 2, -2, 3, -1, and 4, 2. If I plot those, I got 0, 2. I got 1, -1. I got 2, -2. I got 3, -1. And I got 4, 2. So my graph for this one is going to look something like this. What are some things that I know? Well, right away, I can see my vertex is 2, -2. My axis of symmetry is x equals 2, and that is right here. Splits that parabola right in half. X-intercepts for this thing. I'm looking over here for the x-intercepts, and I see, well, it's crossing somewhere in here. And then, I mean, my line's a little crooked, but if it would have been straight, somewhere in here, doesn't really look like they go through a whole number. Interesting. We're not real sure yet what the x-intercepts are. We're going to talk more about this. Our y-intercept, we clearly got one of those at 0, 2. And our a value this time is 1, meaning it's neither stretched or compressed. And this opens up, which means it's got a minimum value at y equals -2. All right. So, in conclusion, graphing quadratic functions in standard form, there's several different things that equation is going to tell you about this graph, and you need to be able to find all of those things. And from the table, you can actually graph that. Your graphing calculator is going to come in very handy for this unit.